Okay, I picked a few problems from last night's page 315. Just in case, since I'm not here today, just in case you need help on them. So what we're trying to do is we're trying to see if EH is a ray. It's going to bisect the angle E here and then explain. So again, we're looking for the two triangles to be congruent. And because this single tick mark is not on the corresponding side here, it does not make these two triangles congruent. And because the triangles are not congruent, we can say no, EH is not a bisector. Okay, coming over to the next one, you can mark this one line in the middle as reflexive, and then you actually do have enough markings. You have an angle, a side, and a side, so we call that HL. So my triangles are congruent by HL. So EH is a bisector. Okay, and then finally on the third one, same thing. You're looking at each one of these, you're looking to show that the triangles are congruent. So even if I mark my reflexive in the middle here, I still don't have enough information to show that my triangles are congruent. So no, my triangles are not congruent. You can say something like, I need the 90 degrees that you had here on this one. You need a 90-degree mark, or you need another side. So you could say you need 90 degrees or a side. That would be sufficient as well. Okay, so that's 9, 10, and 11, but that's the same thing you do for the set right above. So 6, 7, and 8, and the same thing you kind of do for the set below, which is 12, 13, and 14. Then I'm going to skip a little bit. I'm going to skip to number 19. So if you've already done number 19, you can check your 19, or if you haven't done it, do it with me. Some freebies here. If I know that point D is the in-center, then what I'm allowed to mark are the angle bisectors. You do not have to memorize that, because that's going to be on your theorem sheet. It'll say that the in-center is the point of concurrency for the angle bisectors, which means I can mark angle bisectors in the picture. I can also mark my reflexive. So I know that these two triangles next to each other are congruent. So if DC is 9, DB would also be 9. Okay, so that says find DB. It's just 9. In your textbook, it's really nice because the markings are all blue, and so the corresponding markings are all the same color, but it won't be like that for a test or a quiz. So same thing here again, we have an in-center. What we're looking for is HL. HL is this segment here, but HL is the same thing as LK. So I'm really looking for LK. On the triangle for LK, I have two of the other sides, so I can use the Pythagorean theorem. So my Pythagorean theorem, I don't know LK, and if you don't know something, let's just call it X. I'll do 15 squared, and then you always set it equal to the largest side, which in this case is 17 squared. Okay, and then we'll solve. So 15 squared is 225. 17 squared is 289. So we've got x squared plus 225 is equal to 289. We'll subtract to get x squared equals 64. So x equals 8. Okay, going down to numbers 20 and 21. Again, we're still looking for congruent triangles. If you can show the triangles are congruent, then you can go ahead and set things equal. You can use the Pythagorean theorem, or you can say, yes, it is a bisector, or it's perpendicular bisector. So here, what happened was we put the angle bisectors in place, and then someone said that GD and GF are the same length. So GD would be right here. GF is right here. The two triangles that those two are a part of are here and here, and there is not enough information to prove that these two triangles are congruent. So if you want to say that GD is congruent to GF, I need another piece of information like FE and DE congruent, or I need the 90-degree angles at the corner. So these are not, it's not true. It says here it's not true, but why is it not true? It's not true because my triangles are not congruent. Okay. Next one. This one, it wants you to say that TB and TZ are congruent. Those aren't even a part of triangles, but if I bring this line down here and make it into two triangles, this tick mark does not correspond to this tick mark. So same thing. The triangles are not congruent. Okay. Last one that I have printed out here is number 24 and 25. Again, we're going to set this up as a Pythagorean theorem. So we'll go 14x, the quantity squared, plus the smaller of those two, so 24 equals the biggest one, 25 squared, and you will end up with a decimal for this problem.